Now let's start Cisco SD-WAN. Now in this SD-WAN course, we are going to learn how to implement, how to deploy SD-WAN solution, how to deploy SD-WAN overlay, and we will see the policies, routing policies, which can be configured in Cisco SD-WAN. We will see security policies, okay, application aware routing. We will also see QoS implementation in SD-WAN, okay. So now if I talk about SD-WAN or if I talk about WAN, what is WAN? WAN is called wide area network. And why it is used? So when you can define it like this, whenever we want to provide connectivity between two or more networks located in different geographical locations, then we need to implement WAN, right? WAN is called wide area network. It means if you have multiple branches in your organization throughout the country, throughout the world, or throughout the continent, and you want to provide connectivity between them, you need to provide connectivity with the help of WAN. Earlier, we were using different WAN technologies. Can you tell me some of the WAN technologies which were used earlier, जो पहले यूज होती थी? Mr. Vaibhav or Mr. Anish sir?
Is okay. MPLS, Leaseline, VSET, ISDN,
Yes. Frame relay, right? These
okay.
technologies were there. But if I talk about the technologies, these were not that much efficient or feasible so that they can provide you a, you can say, application performance, or you can say performance that can handle application traffic efficiently. Okay. And a lot of cost related problems were there, complexity related problems were there. So we will discuss about them. Okay. So you can say nowadays the enterprise is, you can say, continuously evolving, and you can say the greater demand of mobile and IoT devices is increased, right? SaaS applications, cloud applications, and security needs are also increasing day by day. So applications are requiring prioritization and optimization also. Okay, because this if this complexity grows, then you can say there is a push to reduce the cost and the operating expenses also. Okay, clear. Now, in legacy WAN architecture, we were facing some challenges. Like previously, when we were setting up the WAN network, we were using expensive routers. So the cost was there, right? We were using expensive circuits. Like if I talk about MPLS connectivity, if you are going to purchase MPLS circuit to provide connectivity between your branches or between your different remote locations, you can say located geographically at a wide distance, then you need to set up MPLS circuit, or you can purchase leased line also. But these were all very costly. And to deploy these WAN technologies, we were using expensive hardware also. And we were also putting some engineers to manage them, right? So cost was a big factor. At that time, cost was a big factor because everything was very, you can say, costly. Even this MPLS circuit is itself very costly, right? It is not that much, you can say, cost effective solution. So if I talk about the initial, or you can say the earlier WAN solutions, they were costly, and it was very time consuming to configure all the devices connected in WAN, right? Because traditional WAN does not have any kind of, you can say, tool where you can provide centralized management, where you can provide centralized configuration for all the devices. So in traditional WAN, we were configuring all the devices one by one, and we were doing all the troubleshooting on each device separately, right? So it was very time consuming, like you can say, in traditional networks. First of all, we were using expensive router and switches to set up the network. So it is costly, right? After that, we were using, you can say it was time consuming. It was time consuming and complex to manage or complex to troubleshoot, right? Other than this, even the expensive transport connections were purchased. Expensive transport connections were also purchased. So these things defines the cost. These things define the cost that was applicable in traditional one. Other than this, it was very complex also because each device was creating its control plane. So you can say distributed control plane. Distributed control plane. It means, let's say, if you have hundreds of routers in your WAN, then each router will create its routing table. Each router will run some routing protocol to advertise its network, to, you can say, learn all the other routers routes, right? Every router was responsible to maintain its control plane. So it was also, you can say, time consuming to do that much configuration on the devices. And the remote site management, or you can say network maintenance, was also complex because whenever you are going to deploy a new device in your WAN, right? Whenever you are going to deploy a new device in your WAN, there was no technique to provide zero touch provisioning or plug and play option. It means whenever you are going to connect a router in the WAN segment, then you need to do a lot of configuration to bring that router up according to the network routing policies, right? You need to configure IP addresses, you need to configure routing protocols. For routing protocols, you can configure authentication and other SLA based configurations were there, route map based configurations were there on each and every WAN device, right? But uh, you can say in SD-WAN, we will see these things are very, you can say, efficient to do. Okay. And we will also be able to perform zero touch provisioning for WAN infrastructure devices. But in traditional WAN, we were doing, you can say, remote site management, manual remote site management. There was nothing automatic, right? So we can say manual. It means if you are going to deploy a new remote site, you need to set up WAN connectivity for that site. At that time, you were connecting a router and you were doing all the configuration manually, right? There was no option to do or to provide zero touch provisioning or plug and play. So it was taking very lengthy installation time, right? Lengthy installation time. Okay. Other than this, here we were not able to control the routing that much efficiently because the routing part was done by ISP, right? Let's say you can say, so here I will say routing or yeah, routing is given to ISP's hand, right? We were not able to manipulate the part in ISP code because it was handled by ISP. You can consider an example like this. Here we have different sites, site 1, site 2, and site 3. These sites are having multiple connections, like internet connection is there, MPLS connection is there. Wait, this is site 1, this is site 2, and this is site 3. And now they are having MPLS connection or internet connectivity. Both of the options are there to provide redundant connectivity between these sites. You can connect them like this. Okay. So you can say this is internet, where I will call it inet, and this is MPLS. This is your site one. Okay, then we have site two, and we have site three. Now to provide connectivity between them, we were purchasing these type of connections, right? MPLS link or internet link. The third thing, we were having data centers. Okay, DC. Now in data centers, we were storing all the data which is related to the organization in servers. Other than this, we were also implementing security devices, right? Let's say this is your web server, file server, or this is your mail server. This is your DNS server. Okay, this is your DSCP server, or this is your SNMP server where logs are collected. So all these servers were located in data center. And data center was also connected with these sites. Okay, data center was also connected with these sites. This is connected via internet, and here it is also having in MPLS connection. Further, this data center was connecting these sites to ISP. It means if any site one user will try to access any internet-based application or any cloud-based application, then he has to send the traffic through data center. Right now, I'm talking about traditional WAN, okay, or traditional WAN design. This is your WAN or this is your ISP, okay. Behind this internet, we have different services connected, different, you can say, internet based application services like Dropbox, okay, Office 365. Many applications are there over the internet, okay, cloud based applications, okay, or any other internet based application is there. Now, if these users are trying to access these applications, they need to send the traffic via data center through data center, okay. Through data center. It means if site one users will try to access these internet services, then they need to send the traffic via data center like this. Okay. Now here you will say here also internet is connected, right? Between data center and these sites. This. Now over this internet, here VPN tunnels are created. Let's say this site is going to communicate with the data center, right? So here we establish VPN tunnel between them like this. This site will also create a VPN tunnel with data center, and site 3 will also create a VPN tunnel with data center. Then it will be able to communicate via internet. But when these site users will try to access internet applications, they will not send the traffic via this tunnel. Means they will send the traffic to data center via this tunnel. After that, this data center will send the traffic further. In the data center, we also connect security devices, as I told you. Maybe here you are connecting next generation firewall, then you are connecting your Cisco ICE for identity services. Other than this, NGIPS can be connected. Okay. Or any other security device is connected, proxy device can be connected. So all these devices were stored in data center. Okay. Now in this design, you are purchasing these expensive circuits. You are also purchasing expensive routers and switches to connect all these WAN devices, right? You were setting up the whole data center to manage your data and to provide centralized communication in your organization. You were creating security policies. Everything was there, but here we don't have anything automated, right? We were configuring all these devices one by one manually. So it was also increasing complexity, right? It was increasing cost. So there were a lot of challenges in traditional WAN design. See, this specifically is called centralized security design. Okay, it is called centralized security design. Okay, this is how for now your sites are communicating with the internet or they are communicating with each other. Are you getting this? Any doubt till now? Mr. Tejpal, any doubt?
No doubt.
So far, good.
So this is how we are providing WAN connectivity. But in this WAN, traditional WAN solutions, we have a lot of challenges. So some cost related challenges are there, some complexity is also there, installation time is very high. Okay, if you are going to set up a new branch, then you need to implement or you need to configure the device from the scratch. And it was also time consuming. Now let's talk about Cisco SD-WAN. Okay. And as I told you, every device was creating its control plane. Okay. So control plane was also not centralized in traditional when every router was creating its routing table. If it is configured with MPLS, then MPLS table means forwarding table was created, label based forwarding table, right? So it was, you can say that device was responsible to create its control plane and to perform data plane forwarding also. See, in traditional WAN, if you know, we have four planes of it in traditional WAN. First one, control plane, management plane, and data plane. Okay, data plane. We were having not four, sorry, these three planes were there, not four. Control plane, management plane, and data plane. Control plane means the traffic which is responsible to define best path in the network and to find out the backup path also. Other than this, you can call control plane traffic the traffic which is handled by the CPU of the device. Okay, it is called control plane. Then management plane. Management plane traffic is responsible to provide management access of the network devices. Okay, so you can say that sorry, you can say Telnet, SSH, and the management plane protocol like NTP, SNMP, syslog. These are all management plane protocols. And data plane. Data plane is the user's traffic, real user's traffic. Okay. When and this data plane will be forwarded by the devices. It will go through the network devices. Okay. So these planes were used in traditional WAN. So every device was responsible to create its control plane. There was no distributed control plane available. Now in SD-WAN, here you can say SD-WAN follows the principles of SDN. Okay, SDN. It is the part of SDN first one. So you can say SD-WAN. It is called software defined web. Okay, follows the principles of SDN. SDN is called software defined networking. Software defined networking or network SDN. It decouples the control plane and data plane in the network. It decouples control plane and data plane in the network. Control plane is handled by the centralized controllers and data plane is forwarded or is handled by WAN edge devices. WAN edge devices. Okay. See, if you are going to learn SDN, right? Then you can start it like this. SDN has two parts. SD access and SD-WAN. Okay, SD access and SD-WAN. In SD access, you will learn about endpoint provisioning. Okay, with the help of Cisco DNA, endpoint provisioning and monitoring, analyzing everything. Okay, which will be done with the help of Cisco DNA Center and Cisco ICE. And SD-WAN will help you to learn WAN technology. Okay, which is also an implementation of SDN in WAN. You can say this is the implementation of SDN in WAN, software defined WAN. Okay. So SD-WAN follows the principles of SDN, software defined network. It decouples the control plane and data plane in the network. Control plane is handled by the centralized controllers and data plane is handled by WAN edge devices. Okay. This is the first. Okay. So you can say Cisco SD-WAN represents an evolution of networking from an older hardware-based model to a secure software-based virtual IP fabric. You can write it like this. It is called SEN, Secure Extensible Network. Okay. Cisco SD-WAN creates a secure, extensible network. It is called SEN. Okay, secure, extensible network. It it represents an evolution of, you can write it like this, networking from older hardware based model, or you can say hardware based model, to secure software based IP fabric, virtual IP fabric. Okay. So Cisco SD-WAN fabric is also called overlay network. Is also called overlay network. Will tell you why it is called overlay. It is called SD-WAN overlay network. Okay, clear? Because it forms a software overlay that runs that runs over a standard network transport service. That runs over a standard network transport service. Okay, like public internet, MPLS, broadband, okay, which is also called underlay network. Underlay network. It is like this. Okay. Now, what is SEN? Secure Extensible Network. See, whenever you are going to deploy Cisco SD-WAN solution, then you are going to create a secure extensible network. It is like this. Okay. So Cisco SD-WAN creates a secure extensible network. It represents an evolution of network from hardware-based model to secure software-based virtual IP fabric. Okay. And it is also called overlay network because it forms a software overlay that runs over a standard network transport service like public internet, MPLS, broadband, which is also called underlay network, underlay transport. Okay,
Sir,
clear? Yes.
just I just want to know what is underlay and overlay here. What is the boundary line of, if we say overlay network, so what would
Yes.
be the boundary line of that overlay? And then we can say like,
Cisco SD-WAN solution is
ah,
overlay network.
ah, okay,
Okay. And the transport mechanism which is running behind Cisco SD-WAN with that is called underlay network. Let's say you have internet connectivity in your branches. Okay. And now if you want to implement SD-WAN, you can implement SD-WAN over the internet.
okay,
Okay. This it is like this. That's why SD-WAN is called overlay, and any transport mechanism like internet, MPLS, 4G LTE or broadband, right? These are all underlay networks, underlay transport mechanisms. Okay.
okay,
Yes. Clear. So virtualized network runs an overlay on cost-effective hardware. The hardware is not that much costly. Whether physical routers are called V-edge routers, okay, and virtual machines which are deployed in the cloud, they are called V-edge cloud routers, V-edge cloud routers. Then we have some Cisco SD-WAN controllers which also run on virtual platform. For controllers, we don't have any hardware appliance. I will tell you about the portfolio of SD-WAN components. At that time, we will discuss about it. Okay. Here. So the centralized control plane. See, here I told you that it decouples control plane and data plane, right? So here you can say centralized control plane provides efficiency in managing provisioning and maintenance and security for the entire SEN overlay network. Okay. Let me write this. Centralized control plane provides control plane provides efficiency in managing provisioning and maintenance and security for the entire SEN and the SEN overlay network. You can write it like this. Okay. So the hardware is also very cost effective. Okay. Yes. Cisco SD-WAN will automatically authenticate. Here I can write this that the devices, the network infrastructure devices are called V-edges. For now, we need to understand this term. See, here in traditional WAN, we were connecting some router to the WAN link, right? We were connecting the WAN link with a router. Maybe it is 7200 router or ASR router, CSR router. Okay, some high-end router was used, and that router was very costly. So rather than using that router here in SD-WAN solution, we use V-edge router. We have hardware appliances for them also. Okay, I will tell you about that. We use V-edge router, V-edge, viptela edge, and see, if you are purchasing hardware appliance, it is called V-edge router. If you are going to deploy this V-edge router in the cloud, maybe in AWS cloud or any other Cisco hosted cloud, then it is called vEdge cloud. Okay, vEdge cloud router. Clear? Then we have some controllers. that controller will provide you all the, you can say, centralized and automated environment to perform routing, to implement security, everything. You don't need to connect any firewall at your branches, okay? Because security will also be provided. That's why here I have written security for the entire SEN overlay network, okay? Here you can add Cisco SD-WAN automatically. Authenticate automatically. Authenticate all Cisco V edge routers, Cisco V edge routers when they join Cisco SD-WAN overlay network. Okay, when they join Cisco SD-WAN overlay network. Clear.
What is decouple the control plane and data plane?
See, decoupling means, yeah, decoupling means if I talk about traditional WAN, in traditional WAN you can take the example of MPLS. Okay, in MPLS when we were configuring any router, we were configuring routing also like BGP, OSPF. Then we were configuring MPLS over that, right? So every router was creating its routing table, its control plane information, so that it can forward the packet in the WAN network, right? But here, what is happening in SD-WAN overlay network? Not all the routers will create their control plane. Control plane will be handled by the centralized controller, which will be responsible to distribute the routes. You can say, okay, which will be responsible.
Every
You
router
don't
will
need
have
to.
these. Every router will have the
Yes,
same route table, which will
yes,
be pushed
same
on the
routing table, centralized
centralized.
controller. Yes.
And what does it mean? Like control plane and data plane is managed by centralized controller, and data plane is handled by the WAN edge devices.
Yes, yes. No, no, no. Where we are talking this one. Right.
Just in the above. But yes,
Yes, control plane is handled by centralized controllers, right? And data
and
plane
then
is handled by WAN edge devices.
hmm.
Okay, like
So
WAN edge devices are your V edge routers. Whenever any user will send the traffic through that V edge router, and so whenever any user will try to send the traffic through SD-WAN overlay network, then V edge routers will be handling the traffic. Here you can take an example. I can tell you. Let me this is your site one. Okay. Here you are connecting a V edge router. This is your V edge router. And you have another site. This is your another. Here you are connecting a V edge router. And these routers are connected through MPLS link and internet both. For now, I am taking the example of internet.
okay.
Okay. Now, with the internet, somewhere in your organization, you will set up a small data center or a small environment where you will deploy your controllers. Okay. Here we have different controllers like vManage, vSmart, and vBond. What is this? vBond. Okay. This is your vManage. This is vSmart. I am just writing in short. Okay. Then I will explain all these components separately. And this is vBond. And this data center is also connected with the internet. These are all virtualized controller. For controllers, you don't have any physical device. Okay. This is iNet, for example. Now, whenever any user connected behind these V edges, this is V edge 1 and this is V edge 2. Now, whenever any user will send the traffic from, or you can say behind these V edges, to communicate with the other end user, you can say, then these V edges will handle the traffic. Okay. Data plane will be handled by these V edges, not by the controllers. Here, this vSmart will handle the control plane. Okay. This vSmart will handle the control plane. It will distribute the routes to these vEdge routers, but the user's traffic will be sent from one vEdge to another vEdge and through the VPN tunnel. Okay. A VPN tunnel will be created automatically when these vEdge routers will successfully join Cisco SD-WAN overlay network. It is like this. So data plane will be handled by these vEdge routers and control plane will be handled by vSmart. Okay. vSmart controller. Are you getting this?
Yes.
This is why it is called that control plane and data plane is decoupled. Earlier, control plane and data plane both were handled by WAN edge devices, right? We were creating the routing table and that same device was responsible to forward the data traffic, users traffic also. But here the routing part is done by the controller. Controller will, you can say, distribute the routing information to all the VH devices connected in WAN, in SD-WAN overlay network. Okay. And these WAN edge devices will be responsible to forward to perform forwarding for data traffic for the user's traffic only. Okay.
And does this traffic is being decrypted or any kind of traffic, like how it identifies this application, the what kind of traffic they are
Yeah, here see,
carrying?
when the traffic will be sent through the tunnel, let's say the user connected behind VH is trying to send the traffic through the VPN tunnel. Then VH will encrypt the traffic. And when the traffic will be received on VH2, it will decrypt the traffic and it will send the traffic to the user, internal user. Here the
Uh,
traffic will be encrypted.
yeah, I was asking about you gave this that that you'd be using SDN technology software development.
Yes,
So like it makes your traffic very easy when you're using different applications as you're using Microsoft Office
yes.
365, you're using different kind of applications. So how does it identify those applications?
See, here also it will be using application signatures for that. Here on VH routers, you can perform application visibility and you can say control. Okay. It will be able to identify the application traffic and you can configure the policies according to those applications
So
to,
it
you
will
can say,
some kind
perform.
of, so it somehow decrypts the traffic and runs this
Yes.
hash algorithm and according to
Yes.
it matches with the application ID or something like that.
Yes. Yes.
Forwards
See,
those.
here this is only for application, right? But it will also be able to analyze the, you can say, congestion on the link. Let's say in MPLS network, you can take the example. Let's say you have two paths to send the traffic in MPLS core. Now, one of the path is broken. So the second path will be used, right? If one of the path is down, then second path will be used to forward the packet, right? But if I talk about the congestion, let's say in MPLS network, on one path congestion is occurred. So your route will not be changed, right, in MPLS because it is not detecting the application performance or congestion on the link, right? But in SD-WAN, it will also perform that. It is called application aware routing. So it is based on the application requirement, it will be able to define the best path. Okay, we will see that as well.
And last question,
Yes.
I understand the overlay, but I
Okay.
didn't get the underlay network for MPLS broadband and transport services.
See, underlay can be any transport service. In case of SD-WAN, see, SD-WAN is overlay network, right? Overlay solution. Overlay means whenever you are going to provide connect SD-WAN connectivity between your sites, first of all, these sites must have some underlay transport mechanism. It can be internet, it can be MPLS, it can be 4G LTE. You will be able to deploy SD-WAN over any transport service. This is the thing. So underlay is your transport service which is being used.
Means your fabric circuit.
Yes, your physical fabric, you can say, right? That is
That's the
different part.
underlay.
Yeah. Yeah, that is
And
the underlay
overlay,
thing. Overlay is
over.
SD-WAN solution.
So a
So
overlay
Whenever,
network is like it is creating a virtual
Yes,
layer
virtual IP fabric.
top of the internet,
Yes,
and this VM, VS, VB, and VE, all these
yes,
combination of these four are creating a virtual layer top of the
yes,
internet.
yes,
Correct? Okay.
yes. It is called virtual IP fabric itself.
So
Okay.
all the corporate traffic which we have defined will be going over the internet and will be managed over the virtual
Yes, virtual
VMs.
IP fabric.
Uh,
Yeah, you can say virtual VMs, but for VH we have hardware appliances also, right?
I mean the virtual management and virtual smart virtual board.
Yes, yes. V smart, V bond. See, this V for virtual. It is not V for virtual. Okay, it is V for viptela here.
Sorry,
If I am talking about V manage, it is viptela manager. V manage, and V smart viptela smart controller. V bond viptela bond controller. Okay, viptela devices. V edge viptela edge device.
Those are like vManage, vBond, vSmart are available only in software mode, right?
Yes, in virtual
Or
machines. Yes,
virtual
no
machine, not
appliances
in
available.
not in hardware, right?
No, no.
Okay.
So we will see the deployment of the controller. You can deploy them in your private cloud, in public cloud, or in Cisco hosted cloud. These are three options. Okay. But there is no hardware appliance. And for vEdge routers, we have hardware appliances. vEdge 100 is there, vEdge 1000 is there, vEdge 2000 is there, vEdge 5000 is there. Okay. And for the cloud, we have vEdge cloud. Okay. So centralized control plane provides efficiency in managing provisioning, maintenance, and security for entire SEN overlay network. Okay, SEN means secure extensible network. Cisco SD-WAN automatically authenticate all Cisco V-Edge routers when they join Cisco SD-WAN overlay network. So we will see how this authentication will be performed. Okay. Now, to understand it more clearly, I'm going to show you a picture. Give me 1 minute. Not in this folder. Okay, let me scroll up quickly. This one. Okay, I will give this PPT to you. Okay, you can see this in this secure extensible network. Here we can start from here any location. You can deploy SD-WAN for branches, for co-locations, remote sites, okay, and for cloud applications also. Over any transport, satellite, internet, MPLS, 5G, LTE, to host any service, branch security, cloud security, application quality of experience, okay, voice and collaboration, cloud on RAM, over any deployment like you can provide deployment on premises, cloud, or multi-tenant. Okay, clear. So this is your SEN. So you will be able to deploy Cisco SD-WAN overlay solution for any location, over any transport, to host any service in any deployment. Okay, are you getting this? Now let's discuss about Cisco SD-WAN architecture. If you have any doubt till now, you can ask me. So now when you are going to deploy SD-WAN, how it will look, I can show you. Here, for example, you have site 1, site 2, site 3, site 4, and this is your virtual, you can say, data center. Okay. Here we have MPLS connectivity and internet connectivity. Now all these sites are connected with MPLS and internet. Or some of the sites are having only internet connectivity. It's up to you. How do you want to define it? Okay. So this is your MPLS cloud, you can say. and this is ISP. Okay. Now in this virtual data center, I am connecting vmanage, vsmart, and vbond. It is having the connectivity via MPLS also. Okay. So on these sites, this is site 1, site 2, site 3, right? On these sites, you will connect V-edge devices, V-edge routers. Here, you are not going to connect your previous Cisco routers. I will tell you some of the model number, or you can say some of the router appliances also supports SD-WAN solution. Okay. So I will tell you about them. Not all the routers. Some of the model numbers supports SD-WAN solution. Okay. So I will tell you about. Like some ASR routers are there, and ISR routers are also there. They support this SD-WAN solution. Okay. So these are all V-edge devices for now. This is your vmanage, you can say. Let me write it. Not like this. This is your vmanage. Here I will write it. Then this is your vsmart. And this is vbond. Okay, this is how you are going to implement SD-WAN. Okay. So all these V edges will be authenticated whenever they are going to join SD-WAN overlay network with the help of vBond controller. Okay. Now let's discuss about SD-WAN architecture. Now in Cisco SD-WAN we have four planes. Okay. In Cisco SD-WAN we have four planes. In Cisco SD-WAN we have four planes. First one is called orchestration plane. Orchestration plane. Then control plane. Then management plane and data plane. Okay. These are four planes available in SD-WAN. Now, this orchestration plane is very new here, right? It was not earlier, it was not available in earlier or traditional WAN. Orchestration plane is handled via vBond. vBond controller. Okay. Control plane is handled with the help of vSmart controller, which is also a controller. I am writing it for now. Further, we will not write controller after every device. Okay. Then we have management plane. It is handled by via vmanage controller. It is also controller. And data plane is handled by vEdge router, not controller. Okay. vEdge router. These are infrastructure WAN edge devices. Okay. Clear. Orchestration plane, control plane, management plane, and data plane. In Cisco SD-WAN, we have four planes. Now, if I talk about orchestration plane, what is orchestration plane? Orchestration plane will control the control plane or and management plane, you can say. Orchestration means provisioning of V-edge devices, okay, or provisioning of Cisco SD-WAN components, okay. All the Cisco SD-WAN components will come to vBond to perform provisioning to authenticate themselves. It is the first point of authentication. Okay, so here you can say that orchestration plane is responsible for provisioning for provisioning and authenticating all the Cisco SD-WAN components in SD-WAN over the network. Okay, it is handled by vBond orchestrator. Okay, it is handled by vBond orchestrator. So orchestration plane is responsible for provisioning and authenticating all the Cisco SD-WAN components in SD-WAN overlay network. It is handled by vBond orchestrator. It is the first point of authentication. It is the first point of authentication. Here, when, or you can say, it is responsible to give the information of vmanage and vsmart controller to vEdge router to vEdge routers. It requires a static IP address to be configured. Okay, it requires a static IP address to be configured. If it is connected behind a NAT device, which is performing network address translation, then one-to-one translation must be configured for vBond. Okay, one-to-one translation means static NAT. Clear? Are you getting this vBond? How it works, or what is the role of vBond here? It is used to handle orchestration plane. And orchestration plane is responsible for provisioning and authenticating all Cisco SD-WAN components in SD-WAN overlay network. It is handled by vBond orchestrator. It is the first point of authentication. It is responsible to give the information of vmanage and vsmart controller to vEdge routers. It requires a static IP address to be configured. Okay. Any doubt?
Yeah, one doubt is there.
Yes.
Where we are configuring this static IP address?
On the interface of vBond.
Okay, vBond. And
Yes.
do we need any configuration on vEdge also?
Yes, you need to tell vEdge how to reach vBond. Okay.
Okay, so first this vEdge will contact to the vBond
vBond.
controller. Okay.
Yes.
Okay.
So my question is a generic one. Hello.
Yes. Yes. Yes.
So right now we are studying Cisco SD-WAN. In my company we are using Versa, and maybe some other company they are using some other project, Silver Peak or something.
Yes.
So overall, do we have to learn all the vendors, or basic one vendor and rest configuration are same for the vendor or something like that?
See, the
So
concept will remain same.
generic SD-WAN, like,
Yes.
because we are using
That
literally
will
we are using
remain same.
Versa. Yeah.
See, the controller names would be different, you can say, and they will be using some different terminologies as well, right? But the core concepts will remain same. Okay. In every vendor, SD-WAN will work same, you can say. It will be following all the SDN principles. Okay, in every vendor. Clear. In Palo Alto also we have SD-WAN, right? In FortiGate we have SD-WAN solution. So you don't need to worry about that. You just need to be familiar with the GUI because every vendor has a different GUI. This is the thing. Clear. And their vendor specific terms will be different. Nothing more than that.
So in Palo Alto, uh, we are using SD-WAN with Prisma.
Yes, Prisma Cloud.
Yeah, Prisma.
In Prisma, you are going to deploy the controllers, right? And on Palo Alto interface, you will enable SD-WAN solution connectivity. There is an option.
Okay, we'll go for the Palo Alto hardware.
Yeah, that is, see, every vendor has its specifications. So according to them, some terminologies will be changed. Okay, but the core concept will remain same. There also a controller will be used and some WAN edge devices will be used. Okay. After this, we have control plane, right?
So first VIP bond will be configured if you are going to set up.
See, it depends on you. The thing is, you can configure any controller first or second. It depends on you. You can configure vManage, then vSmart, then vBond. It is like this. But in the end, see, first of all, here you will, if I talk about the GUI, you will be able to take the GUI of vManage only, right? So you will be starting from vManage. Then you can deploy vSmart. Then you can deploy vBond. And now, whenever any V-Edge device will try to join this SD-WAN overlay network, it will contact with vBond first of all. Okay, it will authenticate itself with vBond. Then vBond will provide the information of vManage and vSmart. Okay, then it will create control connection. There is something called control connection. Then V-Edge will create control connection with vManage and with vSmart also. Okay. So we will see that process, all the provisioning process of Cisco SD-WAN components. Okay, clear. Now let's move to control plane. Control plane is used to form fabric discovery. Brick discovery. Okay. You know the control plane traffic. Control plane is used to perform fabric discovery, finding, finding, or find out the best path or backup path. This is your control plane traffic. It is handled by vSmart controller. It is handled by vSmart controller. vSmart is the brain of SD-WAN. Okay, it will distribute routing information to all other V edge routers. Okay. Routing information, not only routing information, routing information, security keys, and other control plane data to all other VH routers. Okay. It will distribute routing information, security keys, and other control plane data like TLOC routes to all other VH routers. Okay. Clear. So it will reduce the control plane complexity. Here, each VH router is not creating its control plane, is not maintaining its control plane. It will be getting the control plane information from VH, sorry, VH routers will be getting the control plane information from vSmart. Okay, because vSmart is the brain of SD-WAN. It will take all the routing decisions, means which routes should be sent to VH1, which routes should be sent to VH2. According to the routes, you can create the policies. Okay. Here it will distribute data plane and application aware routing policies to VH routers. You can write it like this, vSmart. vSmart distributes data plane distributes data plane and application aware routing. Application aware routing policy to all VH routers. Okay, to all VH routers. There,
Sir, if we are saying application aware routing, so what is that?
application aware routing, it means, let's say here you can take an example. Let's say this is your MPLS connectivity for now. Here we have a router. Now these routers are connected like this. So let's say there is a user connected behind this router here. Okay. And whenever he is sending the packet to the server connected behind this router, the packet is going via the upper path. Okay. The packet is going like this. Okay. Now, if this link goes down, I am talking about MPLS right now. Okay. If this link goes down, then your traffic will be shifted to this link. No problem. It will be sent via this link, right? Like this. So this is in the case when your link is down. Now what happens here? Link is not down. Maybe the network link is facing a lot of congestion. Okay. Now, in this case, in MPLS, the link failure will not be detected, right? It will not be considered as a link failure because it is just happening congestion, not the link failure. So, in MPLS, there will be no transition. The path will not be changed, right? But if I talk about SD-WAN, this is called application aware. Here, if the congestion occur on this link, then based on policies, in SD-WAN overlay network, you can change the link. You can change the path. Okay. So based on loss, latency, and jitter, you will be able to create the policies. For the routing, right? Here you are changing the routing decision based on this congestion problem. Right? Are you getting this? That's
Yes.
why it is called application aware routing.
So this path control is managed by vSmart.
Yes, vSmart.
Okay. And what is the protocol that we are using to
Here we have a protocol called OMP.
OMP?
OMP, Overlay Management Protocol. Okay. All these V edge routers will create OMP peering with vSmart.
So BS Smart is deciding like inbound traffic, outbound route manipulation, which route is only defining like how we can handle outbound traffic or
Yes, all the forwarding decision, right? Here, routing means taking the forwarding decision. It will be defined by vSmart, and that information will be sent to vEdge routers.
okay.
Okay, so vEdge routers do not need to create any routing table, or they do not take the forwarding decision. They will only forward the packet. But the information was provided by vSmart that how to forward the packet, right?
So
Now let's move further. We were discussing about controllers. So control plane is used to perform fabric discovery, means to define the best path, to find out the backup path, right? To exchange the routes and keys. Control plane traffic will be used. It is handled by vSmart controller. vSmart is the brain of a Cisco SD-WAN. It will distribute routing information, security keys, and other control plane data to all other VH routers. vSmart distributes data plane and application aware routing policies to all VH routers. Okay. After this, we have management plane. Management plane. Management plane is responsible to provide a single pane of glass for the management and configuration purpose, you can say. Now here you need to configure the policies, right? You need to manage them. So you need a GUI, right? So management plane is responsible to provide management or centralized management for SD-WAN component. It is handled by vManage or vManager. It is handled by vManage controller. Okay. It is handled by vManage controller. vManage provides a single, you can say, pane of glass to perform day zero, day one, and day two operations or to perform all the operations. Okay, clear. It provides the GUI with role-based access control so that we can configure and manage all Cisco SD-WAN components. Okay, with all the Cisco SD-WAN components. We can provide centralized provisioning, provisioning. You can provide centralized provisioning, policy configuration, policy configuration, template configuration, template configuration, and troubleshooting or monitoring and troubleshooting using vManage. Okay, using vManage. Clear? It is your management device. Okay. It also supports programmable interfaces like API. Okay. In terms of API, we can use REST, representational state transfer, and netconf. Okay. Clear. This is your vManager. It is also a controller. vManage. And the last one is vEdge, right? Or data plane, which will be handled by vEdge routers. Okay. Data plane is the user's traffic, which is handled by vEdge router. These routers are also called WAN edge routers. WAN edge routers. These routers are available as hardware appliances and as VM also, virtual machine. Okay, clear. If we have an existing Cisco ASR or CSR router, then we can reimage that router to support SD-WAN. Okay, to support SD-WAN. It is called C-edge router. C-edge router. See, I am writing here Cisco ASR and CSR, but not on all the model numbers. Okay, ASR 1000 supports SD-WAN. If you can re-image it, it means you can download Cisco SD-WAN image from Cisco and you can boot that particular router using Cisco SD-WAN image. Then it will be converted into C-edge router. It is called Cisco Edge. This is C-edge, so Cisco Edge, and this is V-edge, so viptela Edge. Okay. If you are going to use viptela edge, then it is vEdge. And if you have any ASR router or CSR router and you want to convert it into CH, then you need to download the SD-WAN support image from Cisco and then you will be able to do it. Okay. So data plane is users traffic, which is handled by vEdge routers. These routers are also called WAN edge routers. These routers are available as hardware appliance and as VM also. If we have existing Cisco ASR or CSR router, then we can re-image that router to support SD-WAN. It is called C-edge router. When you are using Cisco ASR or CSR in SD-WAN overlay network, they are called C-edge router. Okay. vEdge routers will will create a control connection with vSmart. Okay. vEdge router will create secure control connections with vSmart controller using OMP. Secure control connection with vSmart using OMP, Overlay Management Protocol. I will tell you about this OMP. It will be running between vEdge router and vSmart controller. Now you will say that this vSmart is the brain of SD-WAN, right? So it should be connected in redundant manner. So vSmart can be connected multiple, let's say 2, 4 vSmarts can be connected to provide you redundancy and scalability. Okay. So between these vSmart, if you have two vSmart connected in the network, then OMP peering will be running between these two vSmart also. Okay. So OMP protocol will be running between vEdge router and vSmart controller and between the vSmart controller also. If you have more than two or more than two vSmart controllers, then OMP will be running between them. Okay, clear? It
So how this
enforces.
one doubt how this this vBond and vManage and everything is connected via OMP only, or let's suppose I logged in into vManage and I want to upgrade the version of vSmart or something I have to do with vBond. Let's suppose I
Yes,
want to update the controller. I want to upgrade
yes,
the version. So vManage and how
yes.
vManage and vBond are connected?
Here DTLS tunnels are created between these controllers. Okay, I will tell you about the control connections. In between these controllers, control connections will be created, and these control connections are based on DTLS by default. You can also use TLS as I told you. Okay, but by default the protocol is DTLS. So whenever we bond will try to communicate with vManage, it will establish a control connection using DTLS protocol. So a DTLS tunnel will be created between them, between vBond and vManage, and then they will be able to communicate with each other. Okay, so a DTLS tunnel will be created between them. Here, so it enforces data plane and application aware policies on the traffic, on the traffic. It uses traditional routing protocols like OSPF, BGP, etc. Okay, VRRP also. For redundancy, we can also use VRRP. It supports zero touch provisioning, ZTP. Okay, this is your data plane. So we have these four planes: orchestration plane, then control plane, after that management plane, and data. So we bond, right? Then we smart, we manage, and we edge. These are the SD-WAN components which will be used to set up SD-WAN overlay network. Okay. In our topology, you can see we will use it in our classes. Okay. From tomorrow onwards, we will start initializing the controllers. So here you can see we have different sites, right? Wait, let me edit this. Let me make it bold. Here you can see, is it visible?
for the lab will be getting this access, right?
Yes, yes. I will provide you access to this lab, okay, so that you can perform all the practical hands-on. Okay.
Is there any duration limitation
Yes, for
for
this
the
SD-WAN lab, I will provide you 6 to 8 hours of slot per day. Okay,
6 to 8
to
per day?
8 hours. Yes, per day, and you will be able to do all the practical successfully.
So,
Okay,
I want
don't worry about that.
do we have any lab manual for this?
I will tell you all the things in the class, and I will send you the lab manual to just let you know how to access the lab. Okay,
And
and
the
yeah.
number of the practical is there, like I will, there will be in lab manual it will include all the exercises of the labs, right?
Yes, yes. See, whatever things here we are going to discuss theoretically, I will show you that thing practically also. Okay. So we will initialize all the controllers from the scratch. Then we will perform provisioning for all the V edge routers. And then we will start configuring device template, feature template. Then we will move to policies, then security policies, then application aware policies. Okay. So all the things will be, you can say, completed one by one, step by step. And we will configure this topology from the scratch up to expert level. All the things
Yeah.
will be configured
So
there.
it will be documented in a lab manual with exercises and
See, it is not documented, but when I will perform the practical, then I will note down all the things in notepad kind of, you can say, environment,
okay.
right? So that I can share it with you.
It's,
Like whatever commands I will run on CLI or vmanage or on the router or iOS CA, I will note down all the commands on the notepad and I will share it with you. Okay, so you will not face any problem related to practicals also, right? So here you can see in this topology, we have multiple sites, right? This is your site 5, site 4, here we have site 3, and this is site 12, right? This is site 12. And this is your virtual data center where you are deploying all the controllers, vManager, vBond, vSmart, and this is iOS CA, Certificate Authority. Because I told you whenever any V edge router will try to join Cisco SD-WAN overlay network, it will be authenticated with the help of certificates. Okay. It will be authenticated with the help of digital certificates. So we need to connect a server in the network which can perform a certificate, or you can say which can generate the certificate and distribute the certificate to all the participating devices. Okay. So here we will set up this iOS CA, iOS Certificate Authority. And it will be able to generate root certificate, identity certificate, and we will be able to download them on these different SD-WAN components like vManage, vBond, vSmart, and vEdge routers. Okay, clear? Any doubt till now?
Yes.
it's fine.
So these are the SD-WAN components that we are going to use. Okay, clear. So here, if I talk about the vEdge device, vEdge. Here I can show you the data sheet of vEdge for now. We have different model numbers available for vEdge. Let's go SD-WAN vEdge data sheet. We will see onboarding process of vEdge routers. Okay, how to perform automatic provisioning of vEdge routers in SD-WAN overlay network with the help of ZTP and plug and play. See, this is secure multi-cloud SD-WAN. Any deployment, any service, any transport, any location, right? Then this is the GUI of vManage. We will see it tomorrow. Here it is telling you the features and benefits of the Cisco SD-WAN. Scroll down. Let's scroll down a little bit. I will tell you about licensing also. Okay. Scroll down. Okay. Where is the V Edge datasheet? This is for SD-WAN datasheet. Which one I opened? So we have different VH routers available. Okay. Like VH 100 is there, VH 1000 is there. This is the appliance. This is how it looks. Here it should be showing the data sheet. See, this is VH 100, VH 1000, 2000. We have 5000 also. Just to wait. Wait. We had cloud end of life announcement. This is for VS Cloud. Okay. You can deploy it in KVM or in public cloud also. This is for VS Cloud only. These are images for VS Cloud. Yes. So here we have different hardware appliances. Let me tell you in. Okay. If I talk about hardware series, you can deploy it for small businesses, you can deploy it for mid-size or medium businesses, and for large network also, right? So we have VH 100 for small office, home office, then VH 1000, then VH 2000. I'm just telling you about them. I will show you the appliance also. And VH Cloud. Okay. These are hardware appliances which can be used as vEdge routers. And if you are going to deploy your vEdge router in cloud, then it is called vEdge Cloud. If you have Cisco ASR 1000, okay, Cisco ASR 1000X, ISR 1000, Cisco ISR 1000, and Cisco ISR 4000. These routers can be repurposed, re-imaged, okay, to Cisco SD-WAN images. And these routers will be called as C-edge routers. Okay. These routers are called C-edge routers. And these routers are all V-edge routers, the upper one. These are viptela edge routers. You will purchase this router from Cisco. And these are C-edge routers. When you have an existing Cisco ASR 1000, ISR 1000, ASR 4000, then you can re-image them and you can enable support for Cisco SD-WAN. Okay. This VH 1000 will provide you 100 Mbps speed. Okay. 100 Mbps speed. Throughput of the packet, throughput of the appliance. Okay. Throughput of the router will be 100 Mbps. Then VH 1000 will provide you 1 Gbps. 1 Gbps throughput. Then VH 2000 will provide you 10 Gbps throughput. VH 2000. and VH 5000 will provide you 20 GB plus throughput. Okay, 20 GB plus throughput. Clear? We can virtualize Cisco VH in public cloud like AWS, Azure, and GCP, Google Cloud Platform, or in private cloud like VMware, ESXi, KVM, KVM, and Microsoft Hyper-V. Microsoft Hyper-V. Okay, it depends on your environment. It depends on the requirement. Clear? So this is about your V-Edge routers. Okay. I will also tell you the deployment of controllers. Okay. I will also tell you the deployment of controllers. Tomorrow I will show you the appliance images for these different model number. Okay. It is in my PPT. I can show you here. Scroll down. You can read these points also. How to move from a hardware based network to a software based network. Okay. So you can check that. For now, you can see these are SD-WAN platform options for V-Edge, okay, for the WAN edge routers. SD-WAN with services like ISR 1000, 4000, and ASR 1000 can be reimaged to Cisco SD-WAN routers, and pure play SD-WAN devices are V-Edge 100, 1000, 2000, 5000. You can deploy them in private cloud or public cloud, and these servers can be used to perform virtualization. Okay, so I will share this PPT also. Clear? Any doubt? This is for controller. We will discuss about controller separately.